This video is intended for technicians or authorized users that may need to access the deeper factory configuration screens. There are many things in these screens that are used to set up the custom configuration for each particular generator, so a lot of operational aspects of the system can get messed up and not operate properly if an unauthorized user were to access this. So keep any passwords that you are given confidential and make sure that only authorized people have access to that. When you want to access those screens, the factory button on the menu screen will access that. From this screen, the admin login, you'll have to use these cursor keys to enter the password. This is not the actual password. I'm just going to demonstrate by using the word password. So you would use P A S S W O R D. So if that was your password, you would enter that and then navigate down to the OK button, hit enter, and then that would let you in. And once you've entered the correct factory password, the initial screen that you come to has a, up in the top left, you'll see a watts multiplier. This is set up, this is configured as well as the total watts of the unit to establish the scaling for the two bar graphs, or the top left bar graph on the home screen that indicates the total output power of the generator in 0 to 100%. So it scales it to that. The watts multiplier can be found by measuring the DC volts on the inverter. We'll go ahead and look inside of here. On the inverter, pin number 3 is 0 volts, and pin number 13 is the bus amps output, and that's the terminal that we're reading to indicate the bus watts. So what you would measure is the DC volts between pin 13 and pin 3. It's going to be a value of typically around 3 to 4 volts. It can be plus or minus that, but that value gets entered here. So it's, and for example, this one would have had a value of 3.5 volts, or just under that actually, and you only want to measure that at 100% power, so it's got to be at full power when you measure that. So now this one may have been 3.4 volts DC, and then you would round up to the nearest, because you want to make sure that value is just slightly higher than you would actually see on the DC volts of that output. You drop the decimal so that that would equal 3.5. If it was 4.1, you would enter a value of 41, so on and so forth. The total watts of the unit is what are you actually powering this up to? What is the maximum power when you're running at 100%? For this particular system, this is a 245 watt. It's a 20 gram generator. On this one here, you can read that value on this nameplate, 245 watt unit. Each plasma block will have its own value. If it's a custom Ozone water system cell generator, it will be some other value based on how many cells it has and what the tuning parameters of that system was. So that's just your established maximum power that you want to run through the system. Down here we've got your regulator pressure. That is the desired cell pressure that we want to run the generator at, in this case 10 psi. That's going to vary based on oxygen or air use, whether it's a plasma block or an Ozone water system cell, or any other kind of cell. On the plasma blocks, it could be a Gen 2 system or a Gen 1. That will also change potentially the regulator pressure we run at, also what feed gas is available. So there's several variables you need to consider before you establish what that regulator pressure is. But based on that number, the electronic regulator that we have inside the system will automatically attempt to maintain that pressure. In the middle here we have this is a button for the external interlock bypass. When that's activated, it will ignore the remote external interlock that's often used as a remote run command. Purpose of that would be is if you are a technician trying to operate the system and they are trying to command it to run from a remote SCADA system or remote PLC, and you don't want to track down an operator to help you get the system running each time you need to run it, you can bypass that interlock and run it locally. There is a warning indicator on the alarm list screen that next to the external interlock status lamp that will tell you that it's been bypassed as well, so you don't forget. And an operator can see if you've done that if you forget and leave it on. Over to the right, we have the configuration for what type of feed gas monitor we're using. If you're not using anything, you would switch that to off. In this case, we're using oxygen, so we have an oxygen monitor that will detect oxygen concentration of an intercept, oxygen concentrator, or any other type of oxygen concentrator. If we're using dew point for the feed gas monitoring, you would select this one. And all the screens are custom laid out based on the mode you put it in. So when you switch to oxygen, your alarm list will switch to oxygen. Your values on the main home screen will switch to oxygen. If you switch to dew point, they will of course be custom configured to give you dew point parameters. We switch to down here in the bottom corner, we have our Modbus control. If you are going to use Modbus via the Ethernet connection, you would activate that. As soon as you activate that, the system is now looking for a Modbus watchdog pulse signal to know if you've got a good connection to a controlling PLC. It's also going to be looking for a remote run command via Modbus, and it will also accept an analog signal via Modbus to ramp the generator up and down. And of course, you can always run it in local mode, but it still is going to expect a run signal via Modbus or via the digital input. Will also still work if it's in Modbus mode. It actually requires both. So even if you're using Modbus, the digital input would have to be jumpered out if you're not going to utilize that external interlock. You would jumper that out and then only use the Modbus. Okay. You switch to the Factory 2 screen. Here we establish if the generator you're controlling, it has cooling water. If it's an air-cooled one like this one is, you would leave that turned off. If you activate it, that generator requires cooling water, and it will now populate a icon on the alarm list for cooling water fault or status. The hard shutdown and latching button will configure the hard shutdown function. If it gets a hard shutdown on the generator, such as a backflow or pump status, anytime you open the hard shutdown digital input to the generator, it establishes what it will do. When this is green, it's going to be a latching fault. So in other words, when you get a hard shutdown fault, it will switch the generator to off mode, and then it will require operator intervention to get it back online. If we deactivate the hard shutdown latching, the lamp turns gray, it means it's not enabled. Anytime there's a hard shutdown, the system will stay in its current run mode. It will shut off, of course, and power off, but when the system regains, or that external interlock is re-enabled, or the fault cleared, the system will restart after its built-in delay period once it powers back up. I'll wait for diagnostics. Over here at air prep bypass, if you have a problem with the oxygen sensor or dew point sensor and you need to temporarily override that interlock, you can activate that. The operator will see a warning message on the alarm list telling him that the air prep has been bypassed, so you no longer have protection based on oxygen concentration or dew point temperature. So that's just for maintenance purposes and temporary only. Cabinet temperature set point. This sets the alarm limit for the cabinet temperature. We want to try to limit the cabinet temperature so that the system can operate efficiently. If an internal cooling fan fails on the cabinet, temperatures can get quite hot. This temperature set point will shut the system down if the cabinet temperature exceeds that level. Down across the bottom is where you set the remote control option. The normal default is remote 4 to 20. That will basically take a 4 to 20 external signal either via Modbus or the hardwired 4 to 20 input, and it will, if you have it in remote mode, it will ramp the generator up and down based on that 4 to 20 input. If you have an ORP signal or a DL3 signal and you want to use automatic PID control, you would enable one of these two modes to utilize that function. Now if we go over to the diagnostic screen, this is purely for troubleshooting the system. At the top we have one of our analog inputs, which is scaled from 0 to 100, and then over here that translates that to what volts you see from the PTI. For example, we talked about the bus volts, so that was a 35 value. Over here you would see the 3.5, indicating that was the volts we were getting from the PTI that reflects our bus amperage. Down here we have the gas milliamps. This is the signal that we're getting from our either oxygen sensor or our dew point sensor to tell us what our feed gas quality is. This is just translating that to milliamps so that we can see on here when we're troubleshooting if we've got a good signal from our device what the milliamps is. You don't need to use a milliamp voltmeter to read that. You can do it right from the PLC, which is quite handy. If somebody sets scaling wrong on one of the min-max for the ORP, or a PID controls are set incorrectly, perhaps, if that occurs, you will get an error code on this, and this will turn red. Now you can clear that error once you repair your scaling values so they're in the right range. You can clear that, and then I'll get rid of that PLC error. We can go to more inputs here. This is the external 4 to 20. We can see what our actual 4 to 20 value is coming in. This could be from an ORP sensor, DL3, or just a direct mirrored 4 to 20 signal. I'm going to turn it up and down. So we can see if we move that up and down, we'll see our external 4 to 20 change. Go ahead and move it faster. There you go. You can see that changes the value. Again, you can use that to see how your signal is, if you've got a good 4 to 20 signal or not. Down below, this is the voltage coming out of our cabinet temperature sensor. It's a small sensor that puts out a DC voltage, and this will help us to calibrate that. It's an analog value of 0 to 4095 on that analog input, and that just displays what that voltage translates to. We can also go to some outputs. This is the DC volts that we're sending out to the Ozone generator to ramp it up and down. As we're producing ozone, this is a value of 0 to 1000 is the scaling for that on the raw output, and that converts it to an actual DC voltage that we can read. You can compare that in the generator with a voltmeter to see how that compared. And then this one here is the DC voltage that we're sending out to the pressure regulator, again to 0 to 10 volt signal that will scale that voltage regulator, or that pressure regulator, to give us the right pressure that we want for ourselves. So those are our diagnostic screens. Then we can proceed to factory 3 screen, and in here we have some preset warning values for dew point warning set level. So we have a preset warning at -50 that will pop up regardless of where they have the actual alarm set point set at. We can have a warning pop up because we don't want, even if an operator sets that incorrectly or somewhere out of range, we do want to give them some kind of warning that the dew point is not adequate for the system. Same thing with the oxygen. We've got it set in this one at 80% because we would like to keep it above 80%. But any of these warnings go off, we do not shut the system down. It's merely a lamp that pops up on the screen. There's a pop-up that pops up, and you have to clear that before you can proceed on and look at another screen, just to let the operator know that some parameter is not correct. Cabinet temperature scaling, if a different temperature sensor was utilized, or you find you need to do some calibration of it, this can allow you to set the minimum max scaling of that internal cabinet temperature sensor. And over here we have the oxygen percent scaling, just to help you dial in the oxygen percentage value that we're getting from the analog output of that oxygen concentrator, oxygen board. Output 4 screen. You can also scale the ORP to match whatever ORP transmitter they're using. So a Signet model 9900, for example, this is the standard setting for that, a minus 999 on the minimum to a maximum of plus 1000. Those values can be changed based on what other transmitter you're using. HANA, for example, might be 0 to 1000. Some other Signet blind transmitters can be minus 1000 to plus 2000. So it allows you to set that scaling to whatever is necessary for your transmitter.